So we're going to continue the idea of being a good consumer of math and using everyday math instead of just kind of scoffing at it. And that's going to take us to section 7D. And there's a statement in section D that I really want you to just grab a hold of. And it says, the way that we perceive risks is often disconnected from actual statistics. So our feelings don't always connect to the math, is what that's saying. And so they're talking about situations like, especially air travel versus cars. Cars are really dangerous at the end of the day. There's a lot of accidents, and so sometimes we talk about travel risk in terms of accident rate, and it's really high. And there's a pretty high death rate with cars as well. Like, it's highly likely you know someone who's had a fatal car accident. And we know that about cars, and yet we drive our cars all the time, and we have this fear of planes, which have a much lower accident rate and a much lower death rate. So why are we scared of flying? Why would we even quantify risk? We're scared of flying, again, back to that perception. The crashes on airplanes are a lot worse than the crashes in the car, like generally, right? So even though there's less of them, they get more attention, they take more out of us emotionally, and that's our disconnect. We have a similar disconnect with terrorism. Like, we are pretty scared of terrorism, even though that's something in the U.S. we have a really low probability of interacting with. So it's important that we quantify risks so that we can kind of handle the things that are more likely to actually happen in our life. Like, you are way more likely to die of a heart condition than you are terrorism. So instead of spending like all of our days prepping for a terrorist attack, we should be eating healthy and trying to take care of our heart. That's the kind of making decisions we're talking about here. So one definition, I don't have it in definition blue, so let's get it there. Vital statistics are just data that contains either births, deaths, or life expectancy. So we're going to cover a few things out of this section. The first is life expectancy. So here's another definition. That's an eraser. That ain't going to work. Sorry. Let's highlight it in blue. Life expectancy, we're going to pretend like that's blue, is the number of additional years a person of a given age today can expect to live on average. Now, is this a promise? Like, do we know exactly how long anyone's going to live? Nope. But we've gathered data and put it in this beautiful graph. And let's review some graph stuff real fast. Remember, this is our horizontal axis. It should be labeled. It's labeled age and should have a consistent scale. So these are all 10 years apart. And it should have a vertical axis with a consistent scale. It doesn't have to match. In this case, it does. They're all 10 years apart. And it should have enough information at the top and a title that you know what's going on. So this is life expectancy just for the U.S. for people 0 to 100. There aren't enough people after 100 for this to really matter. Okay? Let's read this. So using the figures shown, we're going to find the life expectancies of a 20-year-old person today and a 60-year-old person today. Now, these graphs are going to change as life changes, as life happens. Every year they're a little bit different. I think this one's from 2018. So let's look at the life expectancy of someone who is 20 years old when this data was published and when 60 years old. So this is our age, so we're looking down here. So for 20, we're looking at this data point right here. And for 60 years, we're looking at this data point right here. So we see here, 20-year-old has a life expectancy of 60 more years. So we expect them to live to around 80. Now, we know some people are going to pass away before that. Some people are going to live after that. Again, this is an average, like the in-the-middle age. If today someone is 60, that actually puts them up here a little above 20, so we're going to call that 24-ish, 24 more years. Interesting, the question is, are those numbers consistent? Now, they're not the exact same, are they? But this one would end up letting someone be about 80, and this one would let someone be about 84 as the expectations. So why are they slightly different? That's a really good question. I'm glad you asked. They're slightly different because we know not everybody who's 20 will live 60 more years. But if you've already made it to 60, some of those things that might have stopped you from getting to 60 are out of the way. Like, you've already made it this far, you're actually more likely to live a little bit further. That's why there's actually some numbers here still at 90, even at 100, you're guaranteed a few more years, because once you made it to that point, just on average, you can expect to live a little bit longer.